Hello. Welcome to this new video. This time I want to pick up on a previous topic of a video that I created earlier where we discussed the different types of man-in-the-middle attacks. It was just a lecture. It was no demonstrations of any tools or anything. And we went over the different types of, or the most popular types of man-in-the-middle attacks. We talked about email hijacking, ARP poisoning, session hijacking, IP spoofing, so on and so forth. This time I want to go a step even further where we're going to demonstrate how the attack works. In this case, we're going to be talking about just one type of attack, and that is ARP poisoning. So you understand the technicality behind the attack, and with that understanding, you can take the necessary actions to make sure you implement the proper security controls in your organization to prevent that type of attacks. So let me talk about the architecture that we have for this exercise. So we have a simple network, as you can see here. All devices on this network are on the same segment, as you can see right here. Number two, all devices, even the attacker or the attacking computer, that's going to be the man-in-the-middle attack. Actually, I said that before. It is in the same network. And this is not a small feat, right? Like many people think that, like man-in-the-middle, you have to. It's a super simple thing to do where you only connect one computer. And yes, depending on what you are doing and the type of setup that is on the infrastructure, it may or may not be simple. But just getting yourself into a company sometimes is the most difficult thing. You have to badge in and you have to identify who you are. And then once you gain access to the computer, if they have some type of security controls in place, you have to connect to the switch. Maybe that switch is not enabled if you find one of the network ports on the wall, or it's part of a different VLAN, or they have some type of network access control system. So what I'm trying to say is that this video is for demonstration purposes so that you can learn and perhaps get some of these understanding, some of this concept to improve the security of your network. But it's not going to be one of those things like plug and play. It's not that you're going to be MacGyver and magically things are going to work, right? It's not going to be like that. But with that being said, so we have a Windows 10 computer that is going to be accessing an SMB share running on Ubuntu. And as you could see, I have the MAC address of each device that are associated to the IP address, or I should say I have the IP addresses that are associated to the MAC address. Now, I do not want to spend much time into MAC address resolution. I hope that you know this by now. If you don't, let me know and I'll create a video for that explaining in details how MAC resolution works. But what's going to happen is that for devices to communicate within the same network, the devices need to know the MAC address of the other device, right? It's not only based on IP addresses. There's one more resolution, and that's going to be MAC address resolution. And depending on the configuration that you have, you're going to be able to lock down the switches if you have a managed switch, depending on how advanced that is. So if an organization has advanced security controls, you can forget about this. It's not going to work, but the concept will, right? So you can try maybe over Wi-Fi and not over Ethernet. But with that being said, so what we're going to do, logically speaking, this computer is going to communicate over the SMB protocol and access the shared drive on this computer, and this computer is going to be able to download and upload files. Now, with a man-in-the-middle attack, what we are going to do, or how the attack works, is that this attacking computer, which, by the way, is also connected to this physical network, that's why we have the same IP address, we're in the same segment, is going to poison the ARP table of this device, so that when this device attempts to communicate with my Ubuntu computer, instead of sending the traffic the normal way, this computer is going to say, you know what, 192.168.170.17 is on this MAC address instead of this MAC address. As this device doesn't know better, it's going to trust that information that's going to be on the ARP table, which is a table that's going to contain a list of MAC addresses mapped to IP addresses, and that information is going to be there for this device that is going to be altered. So it's going to trust that information, and it's going to send that information to the man-in-the-middle attack. Now, the man-in-the-middle attack, or the man-in-the-middle device, to be successful, it needs to forward that information to the other device, and it's going to have to send that information back from this device to this device. So this is going to be sort of a proxy system right in the middle, seeing the connection. Now, just by having the traffic flow through the man-in-the-middle computer does not, and let me make sure that I say this, does not mean that you are going to be able to decode the traffic that is going through. It depends on the protocol that is being used to establish this connection. If these two computers are communicating over encrypted protocols, you may not be able to decode that information, even though you are going to see the traffic. The other thing that I want to mention, and I should have mentioned this before I talked about this, is that on this computer the traffic is going through, but you need an application that is going to be able to capture that traffic. So on this computer, on the man-in-the-middle computer, we're going to be using Wireshark to capture the traffic and show us any unencrypted traffic. So with that being said, let me go over this one more time. On the attacking computer, the one that we have, the man-in-the-middle, that we're performing the man-in-the-middle attack, you need an application that is going to be able to sniff, to capture that traffic, and that's going to be Wireshark. That application is going to show all the traffic going through. If the traffic is encrypted, most likely you're not going to be able to decrypt that traffic. What you're going to see is gibberish. But if the traffic is not encrypted, for instance, we have FTP and Telnet that are not encrypted, and even SMB, you're going to be able to see some information over SMB. Then you're going to be able to decode, or I shouldn't say that because it's not encoded, you're going to be able to see that information in clear text if that's what the protocol is sending from one computer to the other. With that being said, let's run this exercise. Let me get this down here. So what I have on my computer, something that I should mention is that on your how do you call this? On your man-in-the-middle attack computer, the attacking computer, in order for this attack to be successful, you need to run the IP forwarding command, and this is the command right here that you need to run, sudo systemctl net IPv4, because if you don't run this command, you are going to be able to poison. Let me get this here one more time. If you don't run that command, you're going to be able to poison the ARP table of these targets, but you're not going to be able to forward the traffic. When the traffic goes from here to your device is not going to be able to forward the traffic somewhere else. So make sure that you run the forwarding command, and I'm going to leave this in the description of the video, so it's going to be handy to you. Once you have that information, and once you do, this is super simple. Just go to, in this case, I'm using Kali Linux. Just go to the menu, just type ettercap, and then this is it. And what we're going to be doing here is going to say, you know what, we're going to start ettercap in a sniffing mode. Yes, and this is the only thing you have to pay attention to. Look at this primary interface. If you have a system with multiple interface, make sure you select the proper interface for your device or for this exercise. So if you do on Kali IPA, that's going to show you the IP addresses plus the interface name. As you could see, I have ETH0. That's the one that I'm using right here. So I'm going to accept this configuration. And what I'm going to do now, let me expand this for 1 second. I want to send ARP requests to everybody on the network or to the network that I'm a part of. In this case, let me bring this here. I'm going to send ARP requests from this device to everybody, not only these two computers. I'm going to send a broadcast to the network, right? Saying like, this is my ARP. So everybody's going to be notified that, hey, I'm here. So let me do that. And I'm going to do that by clicking on scan for hosts. And in scanning for hosts, once you do that, you'll notice that I don't see anything. It says, randomizing 255 hosts, scanning, and that is based on the subnet mask that I'm using, a class C. And then it says that I found 14 hosts have been added to the list. You may be asking, what list? This list. You have to click on this list button right here. If you hover over it, says, what is a host list? Now, this is where we are going to select the target devices that we want to do the poisoning. At this moment, by doing this, we are not doing anything, right? So we have to select our targets. So for my first target, I'm going to say my Windows 10 computer, which is this one right here. As you can see, this is the MAC address DEE9. I'm going to say this is going to be my target 1. It doesn't really matter which one is 1, which one is 2, as long as you select the computers that you want to perform this attack on. So I'm going to click on add to target 1. And as you could see, it's going to show you right here that 172.168.170.14 has been added as my target 1. Now, I want to select my target 2, and my target 2 is going to be that 17. So I'm going to come here and I'm going to see that 17, and this is the MAC address F9EC, as you could see right here, and I'm going to click on target 2. So that has been added to target 2. So what I'm doing in this case, I am prepping the environment to do the poisoning. Out of all possible computers and devices that could be on this network, right? Let's say that we have more. I have selected these two. And that's what target 1 and target 2 is. So what I'm going to do, I'm going to poison the MAC address of this device. So when this device attempts to communicate to this device right here, instead of finding that device by the MAC address of, blah, 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 ending on F9 in this case, or DEE9, they're going to come to this, right? I'm going to say, you know what? I am both MAC addresses. Come to me. And they're going to establish the communication through me. And that's what I'm going to do now. I am going to perform the attack. And the attack, let me get rid of these graphics. You're going to come here to man in the middle menu. And then what we want to do is ARP Poisoning. As you can see, this tool offers different types of attacks that you can perform. So I'm going to click on ARP Poisoning. And do you want to do a sniff remote connections? Yes, please do it. And there you go. The magic is happening. Now, you don't see anything here. But if I go through, let me bring back my other menu right here. If I go through, let me log in. If I check the ARP table, I have to log in one more time. So I'm gonna see that 14, right, this IP address 14, the real MAC address ends on DEE9, but if I look at the ARP table, it says that 14s end on 16 0, because what happens is that, again, this device send unsolicited ARP messages to the network saying I am it. Now remember, in this example we're looking at the communication between these two devices. We're not taking over the gateway because the communication is in the same subnet. It's not gonna go through the gateway. This is just within the subnet. Maybe we can do a video right here to capture traffic going out to other subnets or the internet. Let me know if that's something that you'll be interested in seeing. So let me minimize this one more time. And what I'm gonna do, I'm gonna start Wireshark on this device, because at this moment the traffic is from here to here is going through the man in the middle. So remember what I said before, you need an application that is going to be able to sniff, see the traffic and capture the traffic so you can have visuals in it. So what I'm going to do, I'm going to start an ICMP. I'm going to start pinging from here to here, and we can see how the traffic is going to be captured right here. So I am running a continuous ping from the Windows 10 to the Ubuntu. Let me come to my Wireshark and I'm gonna start a new capture. And as you can see, I'm seeing the traffic here, right? So let me stop this for 1 second. As you could see, I see the ICMP traffic going over from, again, let me bring this back one more time. The ICMP traffic that is supposed to go in directly is going through this machine, and I'm going to be able to capture that. Now, that is exciting, but it doesn't provide much information. But something you have to keep in mind, remember what I mentioned before, if or not if, depending on the protocol that these two computers are using to communicate, is whatever information you're going to be able to capture. Now, as I said at the beginning, in this case, the Windows 10 is going to be accessing SMB on this device. So let me connect to this device and see what happens on the capture. So I am initiating a SMB connection. And as you could see, I see SMB2 traffic over there, and now what I'm gonna do, I am gonna transfer a file over from this computer to this computer, and I'm gonna stop the capture. Now, as you could see, there's a lot of SMB2 traffic. Let me filter by SMB, and you're gonna see a lot of commands in here. The SMB message protocol, blah, blah, blah. What about if I do SMB2? You're going to see more of it. As you could see, access denied. It said, you know what, I was able to request and access the SMB share. Then it denied me. Then at one point, I was able to see a lot of information. So what I'm going to do here, a name collision, is because I was trying to upload a file with the same name. But what I want to show you, instead of going through each packet, I'm going to right click on it and I'm going to go to follow and TCP stream. So we're going to see the communication that was able to be captured by Wireshark. A lot of it you're not going to be able to decode, but some of it you're going to be able to read in plain text. So let me come here. And as you can see here, there's like, this is my new Phantom wallet that I created after the other was compromised, and this is one of the many codes, and remember, company elements. So depending on the protocol that you're using, you're going to be able to read some information. As you could see, SMB didn't have much information, much like it was in plain text, not 100% plain text, but I was able to read and decode the information going SMB. Now, if the information is going over a telnet, it's going to be the same thing. If the information is going over FTP, it's going to be the same thing. That's why it is better to use secure versions of those protocols like SSH or secure FTP. But this is how you're going to be able to do this. Now, let's do a quick recap right here, because there's something I want you to understand out of this exercise. Number one, remember that you need to be in the physical network and you need to bypass any other physicals and security controls they have in place to do this. Number two, if this network that we're talking about here has a network monitoring solution, whatever solution, an IPS, an IDS, or any type of network access control, or 802.11x, or anything else, any type of port security enabled on this network, this type of attack, as it was described here, is not gonna work. It's gonna get blocked. It's gonna get identified right away. This is one of the simplest type of attacks that are gonna be able to get identified by proper security controls. If you have a real, not an antivirus solution, an endpoint and EDR, endpoint detection and endpoint response and detection solution on your device, like Sentinel-1 or one of those like real like Falcon solutions, this ARP poisoning is gonna get detected right away. So keep that in mind whenever you are looking at this. These type of attacks usually have more success when devices are communicating over Wi-Fi, because people tend to get dumb when they are like over Wi-Fi, right? They connect to anything, they trust pretty much anything. So, but anyway, that's how the attack works. I hope this information was useful to you. And if you found this information useful, all I ask is for you to click on the like button, consider subscribing to my channel. If you know of anyone who wants to learn about cybersecurity, information security, best practices, feel free to forward this video over to them, or you can also leave a nice comment. Thank you for watching this video, and I will talk to you next time.